So the other videos you watched, you were looking at just like the domain, range, kind of all the information you could know about the sine and cosine functions. So one other piece, and I just have this on a blank screen here, but one other piece to look at is, well, let me get to where I'm writing on this. I guess I'll scroll up. Is the amplitude and period. Okay. So the period is how often it's going to repeat. And so here's just the formula for it. So we can look at some of these. And actually, I might be able to stay on this one page. And we'll just find the amplitude and period for each of these functions here. And then I'll graph a few of them. Right? Oops. Okay. So, amplitude is just the absolute value of A, which I should write this. So you got A, and depends on what you have, sine or cosine, it's the same thing. Okay? So, this first one, the amplitude is the absolute value of 2, which is just 2. The period is 2 pi over W. I'm going to quick look up what that Greek letter is because I don't want to be wrong in what it is, but you can see that it's a Greek letter because it's not just W. So hang on. Okay, I didn't want to be wrong. I was going to say it's omega, and it is omega. But yeah, all right, so omega. So the period is 2 pi over omega, and in this case we have 2 pi over, and the number there is 1. So really the period is just 2 pi. Right. Let's look at one that, I will look at a couple of them. We'll do 15, 16, 19. All right. Amplitude is absolute value 6, which is just 6. The period is 2 pi over omega. So 2 pi. Omega happens to be pi. The pi's cancel out, and the period is just 2. All right. Amplitude is the absolute value of -3. So just 3. Period is 2 pi over omega, and our omega here is 3. So our period is 2 pi over 3. Amplitude, absolute value of 5/3. So that's just 5/3. And the period, 2 pi over omega. So 2 pi over -2 pi over 3. So really, let's see, I'm going to erase this. 2 pi divided by -2 pi over 3, same thing as 2 pi times 3 over -2 pi. Those will cancel. So I'm left with just -3. Okay. I guess one thing we should put in here is it's 2 pi over the absolute value of omega. The thing to me was throwing me off with this negative because period is just how often something repeats itself. So the negative doesn't make sense. So it should be 2 pi over absolute value of omega. Right? So we can ignore the negative. Let's do another one. Look, 55 is the same as 19. That's funny. Okay, so let's look at 56 because that's another negative one. So amplitude, absolute value of 9/5. it's just 9/5. The period, 2 pi over absolute value of omega. So 2 pi over absolute value of the negative 3 pi over 2. That's really 2 pi divided by, I'm going to get rid of that negative, 3 pi over 2, which is really 2 pi times 2 over 3 pi. So the pi's will cancel, and I'm left with 4/3. Which is really 2 pi over 1. I guess I should put that. Okay. All right. Let's look at some other stuff. This is a blank page just to have your extra work there. So if you wanted to do all that work I just did here on that blank page, you can go ahead and do that. All right, so we're going to write an equation given some information. And we're going to use a sine function. So amplitude is 2. Actually, let's go back to, do I want to put y equals? Yeah, I'll put y equals. Y equals a sine of omega x. All right, so that's what we're building for. So 60, the amplitude is 2. Well, really, the amplitude is the absolute value of 2. So it could be 2 sine, or it could be negative 2 sine. Our period is 4 pi. So the period formula, 2 pi over absolute value of omega, is 4 pi. So what I can do to solve for omega is multiply both sides by omega. And I get 2 pi equals 4 pi omega, and divide by 4 pi. So the pi's will cancel out, and 2 over 4 reduces to 1/2. So I would have 1/2 x. Okay. Let's look at this one. So again, because it's the absolute value, I could have positive 3 or negative 3. Oh my gosh. And then our period, so 2 pi over omega equals 2. So let's see. I could multiply both sides by omega, so 2 pi equals 2 omega, and then we would just divide by 2. So we actually get just pi. All right. Let's graph one of these. And actually, you know what? I'm going on this blank space. Let's just graph sine of x and y equals 2 sine of x. Okay. I guess before I graph it, let's make a t-chart of values. So x and sine of x. Some good values to use would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So let's do that for sine of x. So sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is 0. I'll put them 0, 0. And the period here, 2 pi over omega. 2 pi is 1, so it's going to repeat every 2 pi. So I could say that's pi over 2. It's pi. 3 pi over 2. And 2 pi. Now I'm just going to plot these points. See, pi over 2, it's at 1. 3 pi over 2, it's at -1. So our sine function is going to look something like that. Our period is 2 pi. So it's going to start repeating again. So I can go up, down, and it's going to keep going in both directions. Okay, something like that. Now let's do 2 sine of x. So the difference here is our amplitude is 2. Amplitude is this distance here. So in sine of x, amplitude is 1. In 2 sine of x, it's going to be 2. So if I make a table of values here, we can use the same numbers. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Still going to give 0 for these 3. But now instead of 1, like I have here and -1 here, I'm just multiplying it by 2. So 2 and -2. So 2, and I'm out of room, we'll just pretend that's -2. And then I'll connect them. And it would go back up and down, both directions. Okay, kind of cool. And you can do the same thing for cosine. So let's look at a cosine one. Kind of graph it with its transformation. So what if we did y equals -3 cosine of 3x? So let's look at the parent function. So just cosine of x. We use the same value, 0, pi over 2, pi, 3 pi over 2, and 2 pi. So in cosine, we get 1, 0, -1, 0, 1. In the transformations, the next thing we would do is the stretch, which is 3. So, I'm going to use the same x. And this time we're only going to apply the stretch. So the 3 cosine of x. So that just stretches everything by a factor of 3. So 1 times 3 is 3. 0 times 3 is still 0. -3, 0, 3. We have another stretcher compression here with the 3. Remember, anything done with the x seems a little backwards, so we have a horizontal compression by 1/3 because of that 3. So 3 cosine 3x. So the y is not going to change. It's the x value that is going to change by a factor of 1/3. So 0 times 1/3 is 0. Pi over 2 times 1/3 becomes pi over 6. pi times 1/3 is just pi over 3. 3 pi over 2 times 1/3. The 3's will cancel, and I'm left with pi over 2. And then that last one is just 2 pi over 3. And then the last transformation we do is right here, that reflection. It's -3 cosine 3x. It's a reflection across the x-axis. So that changes the sign of the y. So x doesn't change. It's the y, and it changes sign. So -3, 0, 3, 0, -3. So now let's look at what that would look like. So I'll do cosine of x, so the original parent function, in black. So we have 0, 1, 2, 3, 1, 2, 3. We have 0, 1. And let's see, in the end, I'm trying to look ahead. We're in the smallest fraction, or smallest denominator is 6. So I'll just go in 6s. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi, 6, combining 7, 8, 9, 10, 11, and 12. I'm going to write it in green, the reduced one. So that's really pi over 3. It's really pi over 2. 2 pi over 3, pi, 4 pi over 3, 3 pi over 2, 5 pi over 6, and 2 pi. Sorry. All right, now it might be easier to graph things, because then pi over 2 is 0. Pi is -1. Oh. 3 pi over 2 is 0. And 2 pi is 1. So if I try and connect these, there we go. It's kind of what cosine looks like. Gosh, I need like better graph paper or something. All right, and now I'll graph the final one after all the transformations were done. So 0 is actually at -3 now. Pi over 6 is at 0. Pi over 3 is at 3. Pi over 2, we're at 0. And 2 pi over 3, we're at -3. And then we could keep going if we wanted to, but there we have it. Trying to think if we want to do another one or not. I think that'll be good. But let's look at going the other way. So having a graph and making the equation. All right. All right, so we're going to look at a graph and come up with an equation. So, and it's just one possible one. We're going to pretend there's no shifting left or right or up and down. We're only going to look at amplitudes and periods. So, this first one here, because it starts up here, this is a cosine function. The amplitude is 5, and the period, so this is from like how often it repeats. So the period is 8. So the period formula is 2 pi over omega. So we have 8 omega 2 pi, and then divide both sides by 8, and we get omega is pi over 4. So pi over 4x. And that's a potential function. All right, let's stick with the cosine and go straight down. Our amplitude is 3. And our period is 4 pi. So let's see, we get 4 pi omega is 2 pi. Divide both sides by 4 pi, and I get 1/2. And the only difference is we are down here versus up here. So that's a reflection across the x-axis. So negative. And there's a potential equation. All right, let's look at these other ones. So these other two, because they start at the origin, 0, 0, these are sine functions. So just find the amplitude, so that is 4. And then the period. So from here to here, let's see, 2, that would be 4, that would be 8. So the period here is 8 pi. So let's see. 8 pi omega 2 pi, divide by 8 pi. It's another one with pi over 4. All right. Let's look at this last one here. So it's another sine function. Amplitude looks like 2. And the period looks like 4. So 4w equals 2 pi. W is pi over 2. And then the only other thing is a reflection as well. So, gotta have that negative. Because usually sine goes like this. So, it reflected. And there we have it.